Hello. So, in this short video, I'll be talking about how AI can be used for mining knowledge out of data. AI has many applications, and one of these applications is knowledge mining. So, why I call it making sense out of nonsense? Because we humans, when we can't understand something, we tend to regard it as nonsense. That's where AI comes in and identifies something very, very valuable, which has been considered as nonsense. So let's look at this example here. So I have this transaction table of sales transactions and items, and in each transaction, certain items are purchased in which are shown by a black dot. Okay, and so this appears to be nonsense. Hardly any pattern except for these blocks kind of things here. So, but when we rearrange this matrix or transaction table, by clusters are identified. So if you look very closely at this image at your left, it hardly resembles. As a matter of fact, these two are identical. So but the biggest question here is that how come or how can this be converted into this? Because when these red boundaries are the biclusters which are extracted and written to an Excel file, and that's the goal. So what's the goal valuable about it? So I'll go to it. Extension cords and plants selling together, so that's non-trivial. Light bulbs and tape selling together, that's non-trivial. So you see that this is seems to be nonsense. This makes sense, and this makes perfect sense, a lot of sense. So where do we get the data? The data is available in hard disks or tapes or drives, or you just name it. So, and of course, then we need to create these transaction tables or other tables or data sets, okay, which are represented in this format. And then, of course, the gold digging takes place. So, what's the complexity of this problem? The complexity of this problem can be best understood by this analogy. So this is ground beef, okay, and this is the steak. So it's trivial. We have seen it many, many times a steak getting converted into ground beef, okay, but never seen, except for movies, a ground beef getting converted back into the steak. So that's the complexity level of the problem which we have, and at a certain scale. So something is are easy and others are very difficult. So what is the problem complexity from moving from here to here? When m is the number of columns and n is the number of rows, so it's not very difficult to calculate. So we see that if for a trivial case for n is equal to 100 and m is equal to 10, okay, that there's a very, very large number of possible solutions. One of them is this one. And on a teraflop machine, this will just take more than 100 million years. So that's not very comforting. So what are the applications of biclustering? Diverse domain, so applications in business marketing, applications in finance, applications in healthcare, applications in security, applications in education, and the list goes on. So the need to tap this, right? So, but as I said that, so we need a reverse meat grinder, a meat grinder which converts the steak back into where the steak came from. That's a difficult problem. Not only a difficult problem, but it's a challenging problem. So we have seen these pyramids of data, information, and knowledge number of times. So we have data, and then based upon certain values, we assign colors to it, those data points, and we have information. And then the techniques which we'll be discussing, they connect those dots of information. And this is not trivial nearest neighbor, because these two tend to be closer to each other, but they are not connected together. As a matter of fact, they can be accessed, but it's a long path here. Okay. So how do we go about doing this? Let me show you the approach which is not going to work. So we have this input data set. Now I've color coded it, assigned color to the biclusters, and added noise seen by black dots, and removed data seen by white dots, and permuted it. And then, of course, apply a dbScan algorithm, very famous one. And of course, it connects the regions, and you can see that it connects even those regions which should not have been connected in the first place, because it does not looks at the semantics of these points, right? So you see that this basically is the red areas, and they are not as they are considered as two different clusters. So the better approach would have been using a Cheng and Chen approach, which also the results are visible to you. So what I'll do is that I'll show you how to simulate the data, because then we can create all types of different biclusters of all different number of colors and everything. Okay. And so that's I'm going to show you which this tool is capable of doing, and then convert that image into a text file, because all the processing takes place on numbers. Text file means that it's alphanumeric. Basically, it's numeric. So using any paint tool or drawing tool, I create biclusters 3, assign, set the shapes of my choice and their colors and everything. And then what I do is that I load uh, those into it. Okay, I load that image, right? That image gets loaded, and then that it is done, right? So when that image is loaded and it's done, then of course I add some noise, 10% noise. Okay, that noise is added, and then permute it, right? And then I save it, right? And I save it, and that gets saved as junk. So let's see how good that conversion has been from image to text and then back to text to image. So I read that clean image, and what I read was not an image but was a text file, and we see that perfect reproduction. And then of course I read this text file junk. You can see the contents here, and then I have a good exact reproduction as was done, right? So we are ready to perform by clustering, because computers run on numbers. So this is a multi-value representation of the input data matrix, and this is the binary representation of the same matrix. And then I perform the bi-clustering, and this is the result. So the bi-clusters come out, they're displayed, and need to extract them. So that's the step number 4, perform bi-cluster extraction. And there are different techniques of extracting the bi-clusters. Set the minimum pixel size of the bi-cluster to be 5, and set the threshold. Threshold is the density of this image, binary image, and which is basically and then use a mutually exclusive approach. So no, so let's go ahead. Then we see that 3 bioclusters are extracted, and they're written to an Excel file, and it takes hardly about less than a second. So now we have these red boundaries here. Okay, so now let's look at the contents of that Excel file in which the data results were written. This is the Excel file. Okay, so this is the nomenclature of the Excel file, and this is the size of the image or the data matrix which we worked, and we set the minimum cluster size to 5. This is the density. 3 clusters were extracted, and it took about like less than a second. And of course this is bicluster number 1, and this is the bicluster size. And initially all the columns were numbered from 1 to 150 sequentially. The rows were numbered 1 to 250 sequentially, but by virtue of biclustering, we see that the order of columns and rows have been changed for more meaningful results. This is the top of the bicluster number 1, and this is the bottom of the bicluster number 1. And the descriptive statistics have been calculated and showed on the screen. And then is bicluster number 2, and then will be bicluster number 3. So what we see that what was once an image, okay, that image got converted into numbers. Biclusters were extracted, and the results written to a text file. And we see that the text file, which is basically an Excel file, right? And now these results can be used in any tool. That's the flexibility. So final results of what we've done. So this is the clean and the simulated input, and then salt and pepper noise is added. This is the salt noise, this is the pepper noise, and then randomly permuted number of times, so that it's more difficult to recreate, get it back. And this is basically the ground beef. And then we perform the pie clustering using the indigenous tool, and we see this the results are not perfect, but they are near to perfect. Okay, so the pie clusters have been extracted, and of course it took less than a second. So when to use this approach? When it makes sense for especially situations with no access to raw data. You have an image and you start working with that image. And educational demonstrations, also exploratory analysis. Of course this the tool which I have discussed, you can it can read text files directly without going through this process of image to text conversion. That's just an additional feature. So let's look at using for real data. So real data, this is basically the survival of patients who have breast and lung cancer, right? And uh, we should all be saved from such kind of ailments. So this is the original data. So do a screenshot, take a screenshot of this original data without doing any cleansing, without doing any ETL and everything. So that saves a lot of effort and time. But of course it has its limitations. And this is that result screenshot, the data image, and that image is then converted into a text numeric, and then numeric is loaded into and displayed as an image. So this is a recreation of this, and of course there is loss of information. So of course you can work directly with the data itself. Okay, do all the processing and everything. So So some loss of information can be observed because it is like almost binary, and but it is like multiple values. So now we can work on it. So let's work on it. So when we worked on it, the results which we got here, this is one result. This is the input, and automatic bicluster extraction results in 230 biclusters, is shown by these rectangles, red rectangles. And when biclustering was performed, we can see that the biclustering has been achieved. And this biclustering will be more useful and exciting if we can actually extract these biclusters. And 91 biclusters were automatically extracted into Excel file. So this is in a nutshell, and thank you for your time. If you have any questions, you're most welcome.